Hello everyone. What are the applications of Poisson processes? Generally, where do you use Poisson processes?
Queuing theory.
If I don't understand queuing, what is meant by queuing theory? Can you explain in layman terms?
Ma'am, anywhere where we are counting the number of events on a specific time scale.
Okay, so can you give me a specific example?
Uh, Number of road accidents on a specific road.
Okay, number of road accidents. Fine, on a specific stretch of road. Okay. And have you guys heard of compound Poisson process or compound Poisson? Yeah, process.
Yes. Yes, ma'am.
Okay, so yes means you have heard in the syllabus or outside the syllabus, because I want to know if everyone has heard
Ma'am, in the syllabus.
in the syllabus. Good, so everyone knows what is compound Poisson process. Okay, so tell me what is compound Poisson process.
With example or some definition?
Example is also fine.
Like in insurance, there are number of people who buy a single policy.
Okay.
So these people are different variables that follow a Poisson process, and the number of people becomes n. So that would be a compound Poisson process.
Can you repeat can you repeat?
And so
Many
there is a
people buy
single
insurance
insurance policy,
policy. Okay, after that.
and uh, and then numerous people buy this single policy. So this number
Wait,
of
wait, wait,
people.
wait, wait, wait. Please repeat this statement. I am unable to hear you.
Okay. So there is a single insurance policy, and
Okay.
many people buy this one policy.
Fine.
So
Okay.
and many people can claim their insurance amount. So this claim amount follows. So this number of claims that they do is the Poisson process, and then there are n number of variables are following this Poisson process at once. So that becomes a compound Poisson.
Does anyone want to clarify it further? I mean, you are there, but I want it in more precise words. Can anyone elaborate more on his answer? Exactly which quantity follows compound Poisson process?
None the total claim amount.
Total claim amount. And what is the distribution of individual claim amounts? Or there is no distribution involved?
Ma'am, exponential distribution.
Okay, so basically, okay. So in that, you shouldn't forget that there are two distributions involved. One is Poisson and there is some other distribution. Okay, so let me try to write what we are saying here. So suppose I receive n claims in a month. Okay, so the total claim amount, if I denote it by T, is I going from 1 to n xi, where xi is the claim amount for ith claim. Is it okay? And two things are random. One, this n is random, and of course these xi's are random. Am I right? N is random and xi's are random. So if this n, how many claims are there that can be modeled by a Poisson distribution? So number of claims, or the count, okay, if you want to be more precise, count of claims follows Poisson distribution with certain parameter, and the individual claim amount, that is xi's, follow certain distribution. It can be exponential, it can be gamma, it can be any non-negative distribution. So let's assume exponential. Fine, exponential with certain parameter. And do we assume xi's to be independent?
Independent, and the distribution should be identical.
Correct. So XIs are IID. Is the assumption of independence correct?
Yes, ma'am.
Why?
Ma'am, the claims are coming from different users, so it
Correct.
should be
Claims are
independent.
coming from different users, so they are reasonably independent. Okay, so I have two things here, and so my distribution of t is going to be affected by distribution of n and distribution of xi's. So this t becomes a compound Poisson variable. Is it okay? This is what you have learned, right?
Yes, ma'am.
So let me now introduce a problem which could possibly be solved via this compound Poisson theory, but without actually knowing the theory. So this much I know. Of course, basic theory you have to know. This much I know. But what is the distribution of t? What is the expectation of t? Of course, you must have derived this. Expectation of t, I think, turns out to be product of these expectations.
Yes, ma'am.
Correct. Similarly, you have formula for variance, etc. But suppose I did not know how to derive expectation, variance, etc. Can I use computer to solve this? That's what we are going to see today. Okay. So let me introduce a problem. Suppose I am working for a bank, or I am working for an agency which sets up ATM. Okay. I am working for an agency which sets up ATMs for a certain bank. Um, so there have been some pilot studies, and or we have ATMs at other similar locations. So we know that on an average, on an average, 10 people are expected to visit the ATM during uh, say 10 a.m. to 7 p.m. and or maybe let me make it 7 a.m. to 7, something like 7 a.m. to 9 p.m. the working hours. Okay, 7 a.m. to 9 p.m. and on an average one person is expected to per hour. Okay, somehow I did not write. On average 10 people are expected to visit 10 people per hour, and one person per hour is expected to visit during remaining hours, means during 9 p.m. to 7 a.m. Further, the average amount withdrawn by a customer is suppose 1500. Okay, average amount withdrawn by the customer is suppose 1500 rupees. Okay, so if I wish to refill the ATM only after 72 hours, not before 72 hours, and I don't want too many people to be unhappy about it. I know I'm framing this in a very vague language, but that's how real life problems come. Okay, you can't do this, do that as step by step problem. And I don't want too many people to be unhappy about that. Then what should be the money storage capacity of my ATM? Okay, so then what should be the amount stored in the ATM? Is the question clear? Is the situation clear? How to solve it is a different problem, but is the situation clear?
Yes, ma'am.
Okay. So I have some things, and okay, so what do I mean by I don't want too many people to be unhappy about that? What is meant by this?
Ma'am, we have to keep the number least possible such that people do not get the cash in ATM methods. Like the
Sorry,
number
sorry.
of people not getting cash should be least.
Okay. I thought you are saying that amount should be least so that people don't get
No.
cash. Okay, yeah, correct. Number of people who have to go back without the cash uh, because they don't have, I mean, because the ATM is run out of cash should be very low. Okay, as low as possible. If so, if you expect like 50% of the people to go without cash, that is very bad. Okay, so now let me list what all we have, and then we'll try to see how this can be solved without uh, knowing too much distribution theory about the distributions. Okay, so what all I know that from 7 a.m. to 9 p.m. we are going to have 10 people per hour, and then from 9 p.m. to 7 a.m. we are going to have one person per hour, and the average amount for all the durations is going to be rupees 1500. So for these two, can I use Poisson as my model, Poisson distribution for estimating the
Yes,
number
ma'am.
of people? Yes. And for amount, what should I use? Perhaps exponential. Why exponential? Or in compound Poisson, why did you generally think claim amount should be exponential if you did that? Yes, someone told me that in compound Poisson, amounts should generally be taken as exponential. Why exponential? Why did you not think of other distribution? Or was it like the simplest answer? Am I still connected?
Yes, ma'am.
Okay. Why not normal?
Here we can consider normal. It's not necessary to be exponential.
Why? Why is it not? I mean, why in compound Poisson was it not normal? Or there also you had this choice.
Even there is no necessity of distribution following exponential only.
Okay, fine. But is there anyone who thinks that normal may not be the right choice for claim amounts?
And uh,
Yes. Anyone who thinks that normal may not be the right choice for claim amounts?
those could eventually lead to a normal distribution, but looking at the numbers, those are not the exact data for a normal distribution because these will be discrete amounts.
No. Don't worry about that. Don't worry about discreteness of the amount. Forget about that because the range is too large. So discreteness is not much of a concern. Any other concern?
Maybe higher, I mean, too much amount, the number of people who want too much amount will be very less.
Correct. So can you phrase it slightly statistically? People are
It
going
will
to
be
hate
more,
me.
it
When
will be
you
more skewed towards
skewed towards
positive, I mean, positively
positively
skewed.
skewed, correct? Yeah, people are going to hate me because when you tell me definition, I ask you layman terms, and when you tell me in layman terms, I ask you statistics. Sorry. So it is going to be generally claim amounts are going to be positively skewed because most of the people will have policies with smaller sum assureds, and but still there will be very few people who will have very large sum assured. Assuming everyone knows the term sum assured. Is there anyone who doesn't know the term sum assured? You're free to say if you don't know, okay? Don't think of what others will think. Okay, fine. So, and here in the amounts also, ideally, yes, because some people would be there who would withdraw probably large amounts. So, I'm more inclined to choose exponential, but of course, our results are going to be dependent on our assumption. So, we have to be very careful about this. But right now, we just want to see the method. So, I will assume exponential here, Poisson here. So what should I do now? I don't know the theory of compound Poisson, but I'm good at programming. So can you give me a way to approach the solution? I can open R, but I thought I would write down the steps first.
Ma'am, basically we have to find total amount required for 72 hours. So
Correct.
what we can do is so 14 hours the rate is 10 people per hour.
14 hours at 10 people per hour.
And then 10 hours would be one person per hour.
Hmm.
So for 14 hours. So that would mean
You are doing this.
15,000 rupees per hour for 14 hours. And then
So number of people is 150 for
yes,
24 hours. Correct? That's what you are saying.
yes, sir. Yes, sir.
Okay. And then average amount is 1500. So 150 into 1500. This is expected amount to be withdrawn in 24 hours. Am I right?
24 hours. Yes,
Okay.
sir.
Okay. And then
Then multiplied by 3.
so this is amount expected amount for 72 hours. Okay. So is my solution complete or do I still need to worry about something else? And some other people should talk. I got expected amount. I did use some theory. I used expectation of Poisson. I used expectation of exponential. This actually I used from compound Poisson, but fine. Even if I didn't know that, logically I would have reached this formula, right? So is my solution complete or do I need to worry about something else?
Ma'am, the making the number of disappointed people to be least.
Huh. So if I put 6
And
lakh,
we'll have to keep some type of cutoff rate for that.
correct, correct. So this 6,75,000 is expected amount. Fine. But as he's saying, there has to be some cutoff. So from where do I get some cutoff? Yes.
From its variance.
How do I get variance? I don't know compound Poisson theory. How do I get variance? Others. And one point I have been emphasizing, that we are assuming that I am good at programming. I don't know theory, but I am good at programming. That's our assumption.
Then we can go for simulations.
Correct. Simulations, and from simulations, what would we find? What would we try to find?
The sample variance.
Sample variance. Okay. And how would variance help me in getting cutoff?
Ma'am, okay, I had this idea that we could place a 5% level of significance in that and then calculate the probability or
Why are we calling it level of significance? I don't have any testing problem here. I'm not doing any hypothesis test. Your idea is right. Put it in the right words. Don't call it level of significance because there is no hypothesis test involved. By the way, others, are you following what is happening? Because everyone is calm and quiet. Or is it like three people are talking and you don't know what they are talking about? Are you following what is happening?
Yes, ma'am.
If you are not following, please feel free to stop me. Okay. Yes. I don't call it level of significance, but the idea is correct. What should we call it? So I want to find some number x such that probability of total amount withdrawn in ATM being greater than x should be something like 5% or 1%. Correct? So what is this number called as? In statistics, what is this number called as? It's not a very fancy term. It's very easy term. Maybe you are thinking too much. Don't think too much and then you'll get the answer. I have to find x such that probability of my random variable taking value greater than that x should be roughly 0.01. What is this x called as?
ma'am quantile or 5% quantile or 1% quantile. Sorry, not quantile, percentile.
Percentile. So I would call it as 99th percentile of distribution of TA.
Ma'am, it can be called as quantile also.
Yeah, it can be called as quantile. Fine. But to be precise, I would call it as 99th percentile. Quantile is fine. Percentile is a subcase of quantile. Okay.
Yes, ma'am.
Okay. So what I have to do is somehow I have to estimate distribution of TA. So my problem now reduces to this. I know distribution of people for two different types of for day and for night. I know distribution of average amount withdrawn. Using all this information, I have to somehow estimate distribution of TA, total amount, so that this 99th percentile of that distribution would be the amount that I should stuff in my ATM. Is it okay?
Yes, ma'am.
And now I'll do this via simulations. I don't have to know the actual theoretical way of deriving this distribution. I'll do this via simulation. So let me try to write a code. Can you see my R screen?
Yes, ma'am.
Okay. So let me call lambda 1 as 10 because we have, or maybe lambda day, lambda night as 1, and average amount as 1500, Okay, and what all I need? Number of hours we are fixing at 72, and why said 72 and wrote 75. 72, and I want to find that cutoff. So cutoff or threshold amount or something like that. So I'll call it as, fine, okay, I won't call it anything. Let me do, okay, so see, what I know is these distributions. So how would I estimate this computationally? As someone said, I'll do this via simulations. So I will actually try to create multiple scenarios. Okay, so I'll see what happens by running this experiment multiple times. So I'll have data. Okay, sorry, where was I? Okay, so let me create a vector for storing total amounts in these multiple scenarios. So I will kind of, run this scenario on computer 1000 times, and in every scenario I will see how much amount is actually being spent. So for I in 1 to n sim, what I have to do? First I have to simulate 14 hourly counts with this rate, right? So day count of people, so R poise 14 with this lambda, correct? Then count of people at night will be R poise 10 with night count, but ideally I have to do for 72 hours. So ideally I should do this 14 into 14 into 3, so 43, 42, and is 30, so that the total is 72, correct? 42 counts for the day readings, and 30 counts for the night readings. Is everyone with me so far?
Yes, sir.
And now for these many people I have to compute the amounts. So the total number of people will be day count plus night count, and the amount now will be REXP. How many exponential amounts? One for each person, so number of people, and with mean equal to 1500, correct? So mean equal to average amount. So let me run for one particular I, and then my total amount is going to be sum over all this. Okay. Oh, I did not run these things. Okay, so these are the number of people I got for 42 hours. Okay, randomly. Similarly, these are the counts I got for night, the 30 hours of night. So the total number of people is, interesting. Nobody stopped me. I should have sum of DC plus sum of NC, right? Because I want total number of people. So total number of people which visited the ATM is 434, suppose, in this particular realization. And then I'll have those many amounts. Oh, exponential doesn't like mean. So let me call it rate equal to 1 by AVG amount. So these are the amounts corresponding to these 434 people. And then we take sum of the amounts. Okay. It turned out to be 7,27,000. Is it okay? If I do this again, I might get different values. So now I got number of people as say 472 in the second realization. So I am repeating this over 1000 times. Let me plot histogram of the amounts, total amounts. Can you see? So if I had just taken average as my cutoff, average was 6,72,000, right? So if I just take that 6,75,000, then on 483 times out of 1000 simulations, so 48% of the times my ATM would run out of money, which is bad, right? So I cannot simply take average. So what I have to do now is quantile of TA and probes equal to 0.99. So this is the amount, 7,81,264 rupees I should store in my ATM to make sure that 99% of the times my ATM machine does not run out of cash. Is it clear?
Yes, sir.
Everyone? See, this is the power of simulations. This is the power of computing. We just had some basic assumption and some basic knowledge, but we did not really need to explicitly derive the theoretical distribution. So people have used this and developed many more sophisticated, this is like very simple simulation, but people have developed many more sophisticated computational methods from this. So we'll be hopefully learning few of these, and I hope we would enjoy this experience. So for today, let me stop here. Thank you.